Membrane proteins have been a targetable protein in the pharmaceutical industry for quite a while now. I mean, even from the beginning of my career, I was in the early days of membrane protein crystallography and getting them to diffract on beam lines and the radiation sensitivity to these membrane protein crystals. Just rewinding and giving everyone kind of a snippet of what that looked like. I mean, we would take a crystal, we collect 5, 10, 15 degrees of data, put up the next crystal and do this for many crystals and then stitch that data set together to form an entire data set that we could then solve the structure of. And that was very difficult. Times have changed, right? Now we have this really nice, diffraction rastering technology where we can take the entire crystal and pepper it with the X-ray beam at a really low dose and figure out where the best diffraction is. And then the new detector technology and goniometer technology in these really hot beams, we can collect a data set in 10 to 15 seconds. And so that crystal that was radiation sensitive now can be collected in such a time frame that you don't get radiation damage. And so from a membrane protein perspective, X-ray crystallography has advanced and it has now allowed for better structure solution on the membrane protein side. And Helix is constantly participating in that. However, a lot of membrane proteins still very, very challenging to produce. And so it all comes back down to the protein production of all of these. And that's where Helix is really starting to make our mark. A couple years ago, we hired into our group membrane protein experts, got into GPCR, ion channel production. And again, this is very advanced protein production skills where you have to go through multiple different constructs and cell lines and detergent solubility screening to figure out what is going to produce a membrane protein that can actually go into either protein crystallography or cryo-EM. And a lot of times, again, you don't end up with the concentration that is needed for X-ray crystallography. One intricacy about membrane proteins that go into crystallography is most of them will go under LCP, which is lipidic cubic phase. It's basically mimicking the membrane itself so that the proteins stay happy and they can actually, instead of aggregating and crashing out a solution, they can actually crystallize. LCP, for anyone that's worked with it, it's a nightmare. It's like growing crystals in toothpaste and looping them out of toothpaste, which again, it's really hard to reproduce them. And you have to have a large degree of concentration for the protein because the LCP is automatically going to dilute the protein concentration by half. And so we're typically working with 20 mgs per mil, 50 mgs per mil on the GPCR front when we do LCP crystallography. Again, if achievable, can be a very great technique. But if it's not achievable, that's where cryo-EM comes into play. Now, just a GPCR on its own is typically too small for cryo-EM. But here at Helix, we have amazing protein scientists that can help design constructs to Lego build GPCRs or other membrane proteins to get them to the size that's required for cryo-EM. And honestly, this is an absolute preferred technique when it comes to structurally characterizing membrane proteins because we don't have to deal with the LCP and we can get away with much, much lower concentrations of protein, which then fits this whole protein production issue where you can't typically produce the amount of protein that's needed for crystallography. So cryo-EM really is that go-to technique lately when it comes to characterizing structures for GPCRs, ion channels, other membrane proteins.